Okay, here's an example of an application of a quadratic equation. We've already seen a few of these, but we graphed them, and now we're going to use factoring. So dock jumping is an exciting dog event in which dogs compete for the longest jumping distance from a dock into a body of water. The path of a Jack Russell Terrier on a particular jump can be approximated by the quadratic function h of d, so height as a function of distance, equals -3/10 d squared plus 11/10 d plus 3. I just about absentmindedly used a Sharpie on my smartboard. That's why I left. Anyway, I guess you had to be here. So h of d is equal to -3/10 d squared plus 11/10 d plus 2. Okay? And so this equation actually varies based on how fast the dog is moving and what angle and all that. But it's a basic quadratic equation, and you know, it's going to look something like that. And I know that because I know that it's going to have a y-intercept of 2. I can tell that from my c value, okay? And I know that it opens down, okay? I know that it's going to be kind of wide, right? But what I don't know is how far it's going to travel, okay? So that's in feet. So h is the height above the surface of the water, and d is the horizontal distance. And all measurements are taken from the base of the dog's tail, not overly relevant. Determine the horizontal distance of the jump. Okay, so what we're going to do is basically, having kind of sketched that out a little bit, I know that when it hits the water, okay, that would be a height of 0. I'm going to have an x-intercept, and that x-intercept is going to correspond to the distance that the dog has traveled. Okay, I will have another x-intercept. It's going to be over here, but I mean, that's mathematically relevant. It's not relevant to my problem because the domain of my problem is only between 0 and whatever that d value is. Okay, so I'm going to factor this. Okay, and so the first thing I'm going to do, I'm going to actually write out my quadratic equation. This is a quadratic function. Now I'm going to write it as a quadratic equation. So set it equal to 0 and find out what values of d are going to make that equation true. Okay, so in other words, solve for d. So the first thing I want to do, I really am not a fan of this fraction here. So I'm going to actually take out a -1/10. Okay, I can't take out a 3/10 because 3 is not a factor of 11, so it's not going to make my second term any nicer. It's not going to make my third term any nicer. So I'm just going to take out that -1/10, and that leaves me with 3d squared plus 11d plus, and then 2 divided by 1/10. So it's actually going to be -20, right? I do that when I say I'm taking out a factor of -1/10. That would be going 2 divided by -1/10. And you know what I did? I forgot to change the sign here as well. Okay. And I'm just going to check that because sometimes that doesn't work so good in my brain. So I just make sure -1/10 of 3 is -3/10. -1/10 of -11 is +11/10. And -1/10 times -20 is 2. Okay, so I know I've got that right. Okay, and then I'm just going to factor. So I'm not sure what's going to be the easiest way to factor this. I think, now I could do it by trial and error. There's not that many factors of 20. There's 1 and 20, 2 and 10, 4 and 5. Okay, so I might try to do it that way. Okay, so let's try. I know that whatever those second parts are, the first term of each binomial is definitely going to be 3d and d, because those are the only things that I could be multiplying together to give me 3d squared. And so it's just these last two parts. And I'm going to kind of start with 4 and 5. Okay. Yeah, and I can kind of see that that's going to work, because when I think about it, okay, I'm going to either put the 4 here and the 5 here, or vice versa. So I just kind of look at what would happen. So when I multiply these, I'm going to get 15. Multiply these, I'm going to get 4. Okay. And so actually, if I make this negative, you have -15 plus 4d, -15d plus 4d, and that does give me -11. Okay. So that's actually the factoring of that. And if you want to stay tuned at the end, I'll tell you when to shut it off if you don't want to see this, but I'll go through and factor that as well by decomposition if you want to watch another one. Okay, and so I have to keep this -1/10, even though it doesn't really give me my roots. Actually, no, I'm not going to do that right now. I'm going to say what there's nothing that I can do to this that can make it equal to 0. Okay, so that factor is not going to give me a root. This factor will give me a root. 3d plus 4 equals 0. 3d equals negative 4, so d equals negative 4/3. Okay, that's going to be this one over here that we didn't really care about. Okay, so that actually is an extraneous root, we call that. And d minus 5 equals 0, or d equals 5. So within the domain of our question, of our real life problem, we only have one root, right? The quadratic function has two roots, but our problem only has one solution. Okay, so we know that the dog travels a horizontal distance of 5 feet. Okay. Okay, and I think in the book maybe they even go through and they check it. Yeah, they do. They put 5 in here. Okay, so when you do that, you get negative 3/10 times 5 squared plus 11/10 times 5 plus 2. Okay, so that becomes negative 75 over 10 plus 55 over 10, okay, which is negative 20 over 10, or negative 2 plus 2 equals 0. Okay, and so that works as a check. Okay, so you can shut it off now unless you want to watch how I do that factoring by decomposition. Okay, so I'd add my negative 1/10 3d squared minus 11d minus 20. Okay, so then I'm going to just going to factor that. I'm going to multiply 3 by negative 20, and that tells me that I need to find two numbers that are going to multiply to give me negative 60, and they're going to have to add to give me negative 11. Okay, so I look at my factors of 60, okay, and I know that I have 1 and 6. Okay, I'm just going to decide, okay? Because these two numbers have to add up to a negative, but they multiply to give me a negative. Okay, the fact that they multiply to give me a negative means that one's going to be negative and one's going to be positive, and the fact that their sum is negative means the bigger one is going to have to be negative, okay? So I'm not going to write like negative 60 and 1 and then 60 and negative 1. I'm just going to write negative 60 and 1. Just make the bigger one negative. Okay, so negative 60 and 1. All right, and then I'll just go up on the right side by 2. Okay, 2 and negative 30. Okay, don't add to give me negative 11 at all. Okay, 3 and negative 20. Notice I'm going up by 1 just to make sure I don't miss anything. Okay, those add to give me negative 17. Obviously, I'm getting closer. 4 and negative 5 and negative 15. Okay, and when I can just, as I go, be summing them in my head or whatever. Okay, and then I know that it's negative 15 and 4 that I'm looking for. So negative 15 and 4, negative 15 and 4. Okay, keep this negative 1/10 because it is a factor. Okay, so I'm going to go 3d squared. Okay. You might be thinking that it matters a lot which one of these goes first. It really doesn't. Sometimes it seems to work better, but yeah, you would get the same answer either way, whether you put the negative 15d first or the 4d first. Okay. And now here, this is where it becomes a little complicated if you don't just separate that off, because you do have that other factor on the outside. So I'm just going to take square brackets, and then I'm just going to go, I'm taking 3d out of here. Okay, that leaves me with d minus 5. Okay, and then here I can just take a 4 out. That leaves me with d minus 5. Okay, and so then this becomes negative 1/10, okay, times 3d plus 4 times d minus 5. Okay, so which is the factoring that we had up there. All right, and just to show you kind of a longer way to do it, if you're not that comfortable with the reasoning and the trial and error, it's really not just kind of it's not too bad to go through the whole process if that's what you're comfortable with.